Welcome back. In this video, I am continuing Leetcode daily question, and for today, that's 2045, second minimum time to reach destination. I'm gonna read it everything out because it's not so clearly explained. So let's go straight to the example. We have this kind of this graph. So we get it by from edges. And we have to go from node 1 to the end node, and node is how do you say it, presented with this. So this is the number of nodes, and we have two parameters, time and change. So each step from one node to the next takes time, so this is the cost, and change parameter is something a bit different. So we have this red green light part. So yeah, this part. Read it out if you want, stop the video, but the idea of that is that for this amount of time we can travel, and when this amount of time passes by, we need to wait change change minutes, so 5 minutes to exit the node. So let me be concrete in this example. In traversing from 1 to 3 to 4 to 5, we can see that situation. So from 1 to 3, that's 3 minutes. We see it by time because each step takes time cost. So this is 3 and change is 5. So there was no change. And when we traverse from 3 to 4, we arrive at 4 at time 6, but change happened at time 5. So from moment 5 to moment 10, there is a red light, and we arrived at moment 6, so we have to wait 4 minutes at node 4 to exit and go to the node 5. And in that situation, so we have 1 to 3, that's 3, 3 to 4, that's again 3, so it's 6. We have to wait 4 seconds, that's 10. And then when we have green light, we can traverse to the node 5, that's 3 more seconds, and that's 13. Also, we're looking for the second best path. This is the second best path. The best path is this. Yeah, so I hope it makes sense. Let's now try to code this up. My approach would be to store best times and second best times for each node. The idea is that we don't want to visit any node more than twice, because if we have visited it twice, we don't have the second best path. So we can see in this situation, at most we have to visit the node twice, and that's in situation if we go from 1 to 4 to 5, again to 4 and to 5, to have the second best minimum time. So yeah, I hope it makes sense. So let's try to code this up. First thing, I'm gonna make a JSON CLS. So in edges, and 1 count, 2, 2. Okay. So I will use Dijkstra or mean heap to traverse and find minimum and second last path. So yeah, I can do, yeah, I can, yeah, keep. So first I'm gonna add node 1. We always start from the node 1 and go to node n with the 0 steps. One thing to note also, I ain't gonna meddle with that change and red green light part with Dijkstra. With Dijkstra, I'm going to find number of steps required to get to the end node, and then depended on the number of steps, I'm going to calculate the time with also red and green part in mind. I'll tell it in code, so send it. Now we need distances, so this distance is 1. Yeah, distance 1 is equal to and also second best distance is 2 equal to okay, because we already added node 1, we need to update distance is 1 of 0 because it's 0 index is equal to 0. Yeah, seems okay. And now let's do extra part. So while heap step steps one is equal to heap q pop from heap steps non heap q heap pop heap. Okay, and new step steps. Okay, and now we only append those neighbors that were visited at most 2 times. And how are we going to know if they were visited 2 times? We check the distances. So first situation, if yeah, for this part, so for neighbor in adjacency list of nodes. So if new steps is less than distances 1 of neighbor minus 1, 0 indexed, we have to update distances both 1 and 2. So distances 2 of neighbor minus 1 is now equal to is 1 of minus 1, and distances of neighbor 1 distance. I'm a bit tired, so it's a bit messy. Steps, and we need to push it to heap. So heap heap push, and we push new steps and neighbor. Oh. Yeah, okay. I'm just thinking if we can have some break part here, but never mind. Let's do part. This one of this one is less than new steps, but new steps is also less than distances 2 of 1. Then we need to update distances 2. And if neighbor is equal to n, then we need to break because we've found our second best solution. And if not, we need to heap. We need to push it to heap. So heap u, heap push. Heap step and neighbor. Okay, so now we need to check how many steps is required. We get it from distances 2 of n minus 1. Yeah. And total time required is 0. So how are we gonna calculate the time? Let me show you. So for this is just a placeholder, steps -1. I'll explain why -1. So in this loop, we are going step by step. So for each step, we need to increase our total time plus equal, total. So it's plus equal time. Time is time to travel from one node to another. And we need to see if we have to wait at that node because we have a red light. And how are we going to know if we have red light? We can do it like this. So if total time is modulo total time by 2 times change, if it's higher or equal change, then we need to wait. Why? So here we have 6 and change is 5, so total modulo 10 is 6. 6 is higher than 5, so we have to wait. You can check it. This is the correct formula. There are other formulas also to do this, but this is the way I'm going to do it. So total is change minus total modulo change. So change was 5, we had 6, and that's 1. So we need to wait for 4 seconds. Why the last step? Because for the last step, we are not interested in red green light because we can arrive at the last node at the red light and we still are at the last node. So we just need to return total plus time for that last step. So it's total plus time. Let's run it. Okay, seems good. Submit. And it's accepted. Let's analyze the complexity. So for the heap, and this part should be n log n for the Dijkstra. And let me analyze if I can. Yeah, I can't. Should be n log n, I'm not 100% sure. And for the space complexity, I think it's also n, just a side input, because we don't have I think so should be not 100% sure. Thank you for following, and I'm sorry I was a bit tired in this video, but yeah, thank you for following and see you in the next video.